From ancient Mesopotamia and thriving in the ancient ruins of Egypt, causing chaos and infecting the innocent through mass plagues and terrible acts of bioterrorism for several centuries. This is Bacillus Anthracis.
Bacillus anthracis is a gram-positive rod-shaped bacteria that is a class of endospores. Bacillus anthracis needs oxygen to sporulate and are therefore classified as aerobes or facultative anaerobes. Endospores are known as one of the toughest to kill. Moreover, produce a capsule made by polyglutamic acid which can evade phagocytosis.
The use of anthrax spores in an act of aggression started in the early 1900s, when the Germans decided to infect the livestock of their enemies through the trade market. This idea of using anthrax as a biochemical weapon was also spread to Japan, who spread this bacteria throughout enemy territory via aircraft. In October 2001, the Amerithrax case was when concentrated anthrax spores were intentionally sent in letter form through the U.S. Postal Services to 2 Senate offices, where more than 20 people were infected with the disease, 5 of which died of the most severe form of anthrax. It has been the last case known of outbreak of anthrax in the U.S. The cause of anthrax was further examined by Robert Koch, who isolated the bacteria through injecting certain animals with anthrax. This led to the establishment of Koch's principles.
Endospores are introduced in the body in one of 3 ways, depending on where they come in contact with the body. The first is cuteness, where endospores are introduced through an open wound and journey into the bloodstream, causing necrotic and swollen tissue. The second is gastrointestinal, and it is caused by ingesting the spores, eventually leading to necrotic lesions on the intestines as well as inflammation. Last but not least, inhalation of the endospores, where they enter the alveolar sacs in the lungs and attach to the tissue. The cuteness symptoms involve black eschers, which are dark lesions on the skin accompanied by severe itchy bumps. Inhalation anthrax and gastrointestinal anthrax symptoms include the chills, fever, shortness of breath, chest pains, nausea, headaches, vomiting, and much more. Inhalation involves more chest pain, while gastrointestinal anthrax symptoms focus more on abdominal pain followed by diarrhea.
Who let the dogs out?
For many years, these spores can inhabit the soil as dormant spores until it is transmitted to a host and activated. The most common target for this bacteria are livestock such as cattle, horses, or other agricultural products such as cotton. In this demonstration, Daisy the Great Dane is the horse.
Who let the dogs out? Who let the dogs out? Who let the dogs out?
As you can see, she is ingesting the spores through her feed without any knowledge that the spores are in there. Once these spores enter her bloodstream, they will germinate and multiply within her tissue, causing infection and may possibly lead to her death if not prevented or treated with the proper vaccines.
So here we have a protective antigen, which is also known as PA63, and this is an anthrax toxin receptor. As it forms a binary complex with the lethal factor and the edema factor, it also binds to the anthrax toxin receptor. Once the protective antigen is activated, complexes bind to the anthrax toxin receptors, assisting in the endocytosis of the toxin complex. So over here, it is shown that the PA63 with the complex is inside the cell, which leads to the translocation. And this is where the edema factor and the lethal factor cleaves off.
Okay, so once translocation occurs and the 2 toxins cleave off of their protective antigen, they're no longer endotoxins, they retain their factors, the edema factor and the lethal factor. So the edema factor utilizes ATP in the cell, which once it utilizes ATP, the ATP is no longer a triphosphate. It turns into cyclic adenosine monophosphate, which is CAMP for short. And once this happens and this occurs, it utilizes ATP. This edema factor inhibits the function of T cells, platelets, neutrophils, endothelial cells, monocytes, and as well the function of phagocytosis. That is the edema factor function once it infects the cell. The lethal factor has a different function. It targets the MAPKK, which is a mitogen-activated protein kinase inside the cell. And this is actually responsible for different biological processes such as cell proliferation, differentiation, and other biological processes. And what happens is the lethal factor cleaves off the N-terminus part of the MAPKK. Without this N-terminus, the MAPKK cannot function in its biological processes. Therefore, when we look up here at the effects of the lethal factor, it can no longer perform cell proliferation or cell differentiation. It cuts off intracellular communication, which is basically the communication between extracellular organisms outside of the cell and also inside of the cell. It also has a major function in immune downregulation, which is basically the host's immune response decreasing. And the way that it does this is it decreases cytokine and chemokine function, which is basically signaling the host cell's immune response. It increases macrophage apoptosis, which is basically the destruction of macrophages. When there's not as many macrophages inside the cell, there's going to be more antigens present inside the cell, which also increases infection. And last but not least, of course, with all this immune response decreasing, this also increases the survival of toxic results.
As mentioned before, once the pathogenesis of Bacillus anthracis occurs, this bacteria causes bacteremia, toxemia, sepsis, and septic shock.
Oh no! What can we do to prevent this?
Well, there are anti-PA antitoxins. So if the host has early detection of Bacillus anthracis, the binding of anthrax toxin receptor and protective antigen does not occur when given the anti-PA antitoxin. Louis Pasteur's discovery of vaccinations was a major component to the effectiveness of anthrax vaccines. Throughout the 1900s, Pasteur used dead strains of Bacillus anthracis for the first time. The most recent vaccine used for anthrax is called anthrax vaccine adsorbed, AVA, which uses aluminum hydroxide and active strains of Bacillus anthracis. This vaccine has shown a higher immunity to the spores. In a study of the precursor for AVA, 92% of the group vaccinated were not affected by the disease, while the controlled group, who had no placebo or vaccine, had 5 cases of infection.
So, how can we prevent the infection of Bacillus anthracis the most?
The main way to prevent infection are hand washing after gardening, mail opening, working in a lab, handling livestock, and get routine vaccinations for livestock if you're a farmer.